In this video, I am going to use the fundamental theorem of calculus part 2 to evaluate the integral. The integral is integral 1 to 16 x square minus 1 divided by square root of x. First of all, let's look at our function, the integrand. So f of x is equal to x square minus 1 divided by square root of x. And consider the limits of integral, which is 1 through 16. We need to ask ourselves the question, is this function continuous on this interval? Only thing we need to worry about is the denominator, which has square root of x, right? Is there any value in this interval that's going to make the denominator 0? The answer is no. Therefore, the function f of x is continuous on this interval. So, by the fundamental theorem of calculus part 2, we know that there exists a function which we call antiderivative, such that that function, if we label it as f of x, the derivative of that function is going to be lowercase f of x. Now this integral is going to be nothing but that antiderivative evaluated at 16 minus the antiderivative evaluated at 1. So now we need to find the antiderivative for this function, which is very easy to find, by the way. So my f of x, I can break it down into two pieces. X square over square root of x, which is x to the power 1/2, minus 1 over x to the power 1/2. If I simplify it further, I'm going to get x to the power 2 minus 1/2 using the rules for exponents, minus x to the power negative 1/2. That, if we simplify further, is going to give me x to the power 2 minus 1/2 is 3/2, right? 3/2 minus x to the power negative 1/2. Now I can easily find the antiderivative of this, because remember, antiderivative of x to the power n is x to the power n plus 1 divided by n plus 1, for n plus 1 is not equal to 0, which is equivalent to saying n is not equal to negative 1. N is not equal to negative 1. So using this, the antiderivative f of x, uppercase f of x, is going to be x to the power 3/2 plus 1 divided by 3 over 2 plus 1 minus x to the power negative 1/2 plus 1 divided by negative 1 over 2 plus 1, which, by the way, comes out to x to the power 5 over 2 divided by 5 over 2 minus x to the power 1 over 2 divided by 1 over 2. And f of x ultimately becomes 2 over 5 x to the power 5 over 2 minus 2 times x to the power 1 over 2, which is just square root of x. Now we need to evaluate it for x equal to 16 and x equal to 1. So let's find f of 16, which is going to be nothing but 2 over 5 times x is 16, so I could write it as 16 square root raised to the power 5. How can I do that? X to the power 5 over 2 is the same as x to the power 1/2 to the power 5, right? Because exponents multiplied. X to the power 1/2 is square root of x raised to the power 5. I put it this way so that you can see it, okay? Minus 2 times x to the power 1/2, which is, by the way, square root of x, which is square root of 16. And that is going to give me 2 over 5, okay, times square root of 16 is 4. So that's going to be 4 to the power 5 minus 2 times square root of 16 is 4, which is 8. Let me go ahead and simplify this thing on the side quickly. So 2 over 5 times 4 to the power 5 is the same as 2 square to the power 5, then minus 8. So 2 over 5 times 2 square to the 5 is 2 to the power 10. So times 2 to the power 10 minus 8. The reason I wrote it down this way so that I don't have to use a calculator. That's about it, nothing else. So 2 times, now 2 to the power 10 is a pretty famous number, which is 1024, okay? You heard the word 1 meg when you're taking pictures, right? So that's 1 meg. Divided by 5 minus 40 over 5, okay? 40 over 5 is 8. So now you have 2048 minus 40 over 5, which is going to be nothing but f of 16 is equal to 2008 over 5. Now f of 1 should be pretty easy to evaluate. F of 1 is just 2 over 5, okay? So I'm just plugging it in here, times 1 minus 2 times square root of 1 is 1. So that's going to give me negative 8 over 5. So my final answer should be f of 16 minus f of 1, which is going to be equal to 2008 over 5 minus, don't forget this minus, put it inside parentheses, 8 over 5, which is going to give me 2008 over 5 negative, and negative is going to make it positive 8 over 5. So finally, my integral 1 to 16 x square minus 1 over square root of x dx is going to be nothing but sum of these two, which is 2016 over 5. So what you want to do before you do the integral mechanically, by the way, I could have done it in a matter of, less than 2 minutes, but I didn't. I want you to go through the steps, because many times people just do this mechanically. Oh, okay, antiderivative, just do it, plug in the values. But I want you to understand fundamental theorem of calculus part 2 and apply it properly. So what I did first, I went ahead and took the function and showed that it is continuous on the interval 1 through 16, which are the limits of integration. Now, once it's continuous, fundamental theorem of calculus part 2 ensures that there exists an antiderivative. So once we know that for sure, we go ahead and take this function and find the antiderivative step by step, okay? And then once we find the antiderivative, then we evaluate it at 16 and evaluate it at 1 and take the difference, and that is your answer, and the answer was 2016 over 5. Now this thing, initially you have to kind of do it step by step by step. Once you have had enough practice, then this will become a second nature to you. Then you can go ahead and do whatever way you prefer quickly. But initially, to ensure that you understand the fundamental theorem of calculus and its application, please go through the steps as I did. I hope that this discussion was helpful. Thank you very much.